Says it will be starting soon. Okay. So we are recording. Hi, everyone. Welcome to the Cosmos Code with Us with Archway. I'm Michelle, and you have Drew and Augusto from the Archway team. Yes, this will be posted afterwards. So today we have Archway, who's going to run us through how to use CosmWasm to build blockchain applications and NFTs. I think a good starting point would be if you guys could post again or explain again the links that people should reference as we kick things off. But before that, maybe introduce Archway, yourselves, and then we can move quickly into which links they should use to follow along. And one other point for everyone, because we want to keep it clean and keep the videos, everything okay here. We have unfortunately had to kind of like make this a co-host situation where everyone has to type in their questions rather than video share, camera share, chat. That's an unfortunate reality of what we've experienced in the past. So if you guys do have questions, pop them in the chat channel, and Augusto and Drew will hopefully answer them either on through the workshop or at the end. But I will hand it over to you guys to introduce Archway, the links that people need to follow for the tutorial and the workshop, and then kick it off.
Hey everyone, my name is Drew Taylor. I'm here with my teammate Augusto. We work for the developer experience team at Archway. For anyone not totally familiar with Archway, Archway of course is a Cosmos blockchain. Kind of the cool thing that we do is in the same way that in the industry, it's common to give rewards for validating or for mining transactions. We also give rewards to dApp developers based on how popular their dApp is. And this is tracked through how much gas is being consumed on the network by this specific decentralized application. And just a bit about the links. So the developer documentation is the go-to spot. If you haven't set up or deployed any smart contracts with Archway, you are going to need to start with the developer documentation. This will help you get everything you need installed so that you can follow along with this tutorial. If you haven't done it already, I recommend just watching it and picking up later, because it does take a bit of time to install all the tool sets, especially if you don't have Rust and Cargo already installed. So if you have already familiarized yourself with all of the tool set and installed everything and you're good to go, the next step will be the Archway templates repository. I guess, Augusto, maybe you can put that link in the chat. The templates repository is where you're going to find some of the code that Augusto is going to walk you through for smart contract development with Rust for Archway. And then the next thing you'll be interested in as well is our dApp examples tutorial. So the decentralized application that I'll be demonstrating today and walking you through, the code for that is there. And we'll get to that shortly. And I also gave you a link to the NPM package for the developer CLI, but of course that is also linked to in the developer documentation. So you probably found that already, but it's there just in case you need it. Augusto, you have anything to add about the links? I see there's the blog and some general information has been added as well as a reference to our past workshop for Hack Atom, which the content that we're going to be presenting today is a bit of a continuation on that. So if you find it difficult to follow along in this tutorial today, it may be worthwhile helping situate yourself by viewing the Hack Atom workshop stuff that we've done. Anything to add, Augusto?
Yeah, just going to introduce myself first. I'm Augusto. I'm working with Drew in the developer experience team. And yeah, as Drew said, this workshop will be a bit of a continuation of the Hack Atom one. And sorry if you if during the presentation you hear some ding dongs. Unfortunately, we cannot unmute. We can unmute that on Hangouts. But yeah, so in the link that I just posted, there are some useful links to other resources and also some useful information regarding the presentation we are doing today. So without further ado, I'm gonna start with the workshop. Let me just share my screen here. Present. Okay. Yeah, let me just zoom in a little bit. I hope the font size is okay. It's readable.
It seems okay for me.
Okay.
I can read it.
Okay, cool. So yeah, so during this workshop, we will walk you through setting up the basic NFT smart contract. I will go through the source code of the contract, just explaining the main entry points. And then after that, Drew will demo front-end dApp that uses this contract to mint and transfer the NFTs. Okay, so yeah, first thing, I already have the CLI installed, but if you don't have, it's just like any npm install Archway HQ/CLI. In this demo, I will be using a new version of the CLI that is still not released. We will be releasing it by tomorrow. So just in case if you already have the CLI installed and you see some differences in the output, it's because of that. But tomorrow you're gonna have it, the new version already ready for you. So first thing, to create a new contract using the templates, you can just type Archway new and the name of your project. So here we are going to use a starter template. And for this template, we are going to use the CW721 with on-chain metadata. The difference between those two templates is that with the off-chain metadata, it expects that the contract, anytime that you mint the NFT, the metadata about it will be stored outside the chain. Like you need to post a link to the JSON metadata. So we are going to use the on-chain metadata to simplify our lives. And right now we only have testnet enabled. Mainnet and local are still to come. And we will deploy this contract in Constantine testnet. And yeah, now it's gonna download the template and build it. So let's just wait a little bit. This is gonna be fast. Okay, so here is, we have the code. All right, so since it takes a bit of time to build and optimize the contract that we will deploy on chain, I'm just gonna switch to a previous code base that I already have. Is exactly the same code base, but it is already deployed in Constantine. So just for you to know, but the same code base, just so we don't waste time building and deploying it again. Okay, so let's get to the code. After you finish after you created the template, let me just Yeah, okay. So after you created the template, you will have well, the cargo project here with this single lib.rs file. This contract, it uses the CW721 base contract, which is present in the CosmWasm base contracts repository. So what this contract does, it implements the base for the CW721 standard, which, as you can imagine, is based on the Ethereum 721 contract standard as well. And the CW721 base is just, it implements basically all the entry point functions, the initialization, execution, and querying functions for these smart contracts. And by using this base contract, we can skip many boilerplate code that we need to write for using this contract. So, as I said, this contract is storing the metadata on-chain. So for that, we need to specify a struct with the information, with the metadata information. And this is what we have here. So the contract metadata will have the link to the image, some external URL if you need, descriptions, and yeah. So all this information that will be, that we can extend this struct if we need, if we want to add other traits, other attributes. For example, you have like those rarity attributes that you can set, like eye color, these kind of things. All of those can be extended in this struct. And going to the contract code itself, we have here the instantiate method for the contract that will, here we are using our custom implementation of it, so we can specify the contract name that we set in this constant here, okay? This is already pre-filled for you with your project name when you create when you create the project from the templates. And yeah, this will basically instantiate the contract, setting some useful information for you, especially the minter address. This is something that we need to specify when we are instantiating the contract. So we allow only one address to mint NFTs in this contract. Let me show you an example of how does this work. I'm not going to run the full command here because this deploy step will do three things, basically. It will build an optimized version of your contract. So this step takes a lot of time to run, especially when you're doing screen sharing. So to avoid hanging here, waiting for the build to finish, I'm just gonna stop after I run this command. But yeah, and in the argument lines here, well, in the args, we can specify an account on your local keychain to use to instantiate the contract. This no confirm flag will just skip any transaction confirmations. So you don't need to if you run it without this flag, it will just ask for you every time you need to do an on-chain transaction, it will ask for your confirmation. And the args here, this JSON are the arguments that are passed to the instantiate function in this message, instantiate message struct. So as you can see, the name, symbol, and minter. And the minter here is the address that the only address that will be allowed later to mint. I'm going to show you. Let me just minimize this. I'm going to show you how does this work. So after the contract is deployed and we are ready to start minting. We will run transactions calling the methods here, the execute method. Okay, this is the main entry point for any transactions that we run in the smart contract. And here, as you can see, we are using these default metadata contracts from, this is declared in the CW721 base rate. Okay, so this is the contract that I just explained, that it wraps for us a lot of boilerplate code, so we don't need to rewrite it. So we are just forwarding the execution of the contract to this base contract. And here is where all the messages are handled. Okay, so all the transaction messages, for example, the mint message and so on, are handled here. So let's go to the mint message, for example. Here in the mint message, we get the minter. This is, we get it from the storage, okay? And then we confirm if the sender of the request is the same one as the minter. Oh, sorry, the wrong link. So we confirm just to, and we throw an unauthorized error if it is not. And then otherwise we allow the address to mint, okay? So let me just check here the status of the build. Maybe we were lucky. Yeah, we were lucky, and we have the optimized version ready, so we can do a live deployment of this contract. And okay, so this is just sending the transaction to first deploy the contract on chain. So now we have the WASM version of the contract deployed, and if you want, you can also check Constantine. And we can look for this transaction. Oops, where is it? For some reason, it's not here yet. But yeah, maybe it's just a lag, but it will show up later. And okay, so now that after we deploy the contract, the CLI will validate if this is if the deployed WebAssembly is okay, and then it will ask for you for a label to deploy. You can, by default, it will use your project name and the current version that you have defined in the cargo file. And now it will proceed with the instantiate to instantiate the contract. And that's it. Now we have the contract instantiated. And this is the address for your contract. And yeah, now I'm just going to do a simple transaction, but this oops. Sorry, I don't have the transaction comment ready here, but we are going to see the transaction happening in the dApp demo that Drew will make. But yeah, I think that for the contract, from the contract side, that's it. Basically, the execution is handled by this default contract in the base crate, and here for the query is the same logic. All the messages are here, and one important thing is, okay, since we have these those messages handled by the base one, what if we want to override any of those messages and just do our custom implementation? It's possible to do that really easy. We can just, for example, do something like this. And for example, if we want to write our own mint logic, we could do something like this, for example. So only the mint message would be handled by our contract, but all other messages would be handled by the default base contract. So this is an easy way for us to override, to use like some base functionality and also override the specific messages when we need. Okay, so yeah, I think that's it from the contract side. I don't know if someone has any questions, but I will hand over to you, Drew, for that side.
Okay, I'm just going to try to overtake the screen share if you want to turn yours off. Okay, cool. Just starting this up. Looks like we're going. So I just did a get remote v, so you can see the repository I'm in. This is the repository that I shared with you in the chat. So it's this one here, our dApp examples repository. And the dApp that we're going to be looking at today to go over the code that Augusto just presented, only have a Vue.js version right now, and it is the NFT basic folder. So most of the code that we're going to be looking at, of course, is in the source directory. And as this is just a small demo application, we're really just going to be looking at this component file, app.vue. Everything should be here. At the top, if you're not familiar with Vue.js component structure, we just have like the HTML code at the top. And if we scroll down long enough, we will actually start to get the application logic. So the main things that we're going to be looking at today is we're going to be looking at connecting a wallet, which is with this method. It's going to be triggered from a button. And when we trigger that button, we'll be able to access Kepler. So this is a little bit different. If anyone watched the previous tutorial from HackAtom, we just connected to end user wallet by a hard-coded mnemonic. So now we have a much more usable way to do this. So we connect to Kepler if it's available, if it's being exposed to the web page window object. And then what we need to do is suggest all the parameters for Archway chain. And this is in the chain meta here. You can see that chain meta goes here. And then this is just a file that we've imported. So if you're interested.
Sorry to interrupt you, but would you mind just zooming in a little bit?
Oh, yeah. Is it too small?
Yeah.
That better?
Yeah, it looks better. Thanks a lot.
It's huge now for me. Okay. Cool. So
someone is asking to zoom in a little bit more.
More?
Yeah.
Wow. It's massive for me.
Very small when we are screen sharing. Yeah.
Yeah. You never know how it's going to turn out, right? And the other thing is I have a very high resolution monitor. So I think that changes things a little bit. Anyways, yeah, keep bugging me if you're not able to see what's going on, and I'll fix it up. So basically, there's a bunch of Archway parameters in the file that we serve to Kepler here. Once we have that, we can enable it. And we enable specifically with the chain ID from our chain meta file. Then we set up our signers and our WASM clients. After we've done that, we can ask the offline signer to list accounts that are in our Kepler. So this is probably a bit of a repeat for anyone who's worked with Kepler on other Cosmos chains. You also might be familiar with this. It basically, like the way that queries work, there are several different query modules that you could use. So most of the time when we're dealing with smart contracts, we're going to use the smart query module. Most of the other modules are for getting things about like metadata about the contract and that sort of thing. So they're not really dealing with the transactions. or maybe it might be dealing with the history of them. But in terms of dealing with the contract state, this is the module that we're most interested in for our dApps. So that's why I just create a little reference to it. So without further ado, let's try to get something going. So I think that this is probably going to be too small for you as well. Let me try to make this larger. Is that readable? I mean, that looks about the same size as the GitHub text.
Good.
We'll go with that. So I'm just going to, you can see that I'm in the project folder at the root of it for the folder NFT basic. So without further ado, we can just go ahead and start this with npm start. Of course, you'll need to npm install if you're setting it up for the first time. The other thing that you're going to need to do is create your M file with your contract configuration. So I included an example. I could type. So that is the example. You'll see that if I do the same thing for my M file, it's actually exactly identical. But something to know is that my wallet address is the minter of this contract. If you just copy the env example, you will be able to run the dApp, but you will not be able to mint unless you deploy your own contracts and put your contract address where you are the minter into your M file. But yeah, let's go ahead and just see what this dApp does for a second. It's just going to build the view modules for a second, and then we'll be able to view this on localhost port 8080. Try to make this one really big too. Hopefully the NFTs still look cool. So get a Kepler sign in. Let me just get my password. Here we go. So as you can see, I have some status information at the top. You know, here is my Archway Kepler address, and this is the balance of Constantine Arch that this address is holding right now. Right now, we're just in the home page, which I called Market, and these are the NFTs which I have already minted so far. I just had a bunch of game art images, so I just made a few tokens around them from the game that I work on. Well, the next thing that we can do is we can start to mint something. And this is line 584 of this file that we were reviewing previously. So let's just go check out what line 584 is like. Forgive the endless scrolling here. It is a large file as I shoved everything into one single view component. 585. Okay, so here you see we have the mint function. And just a quick review of all the things that we're going to do. So the first thing that we need to do is we need to collect form data. So what does that look like? If we go to mint, the form data is we need it's a very basic NFT. So we're going to have a name and we're going to have a description and we're going to have the artwork. So one thing that I do want to point out is that this contract that we've deployed is using the off-chain metadata. So our metadata is going to upload to IPFS. This is a little bit different than what you just saw from Augusto deploying the on-chain metadata, but like setting it up and deploying it through the developer CLI should be pretty much identical. You're just choosing a different template. And when you're minting tokens, there may be a slight difference in the args that you need, but we'll go over that. So let's just, so we talked about form data. The second step that we're going to do, provided all our form fields are filled out here in our application, we're going to upload the image first to IPFS. We do the image first because there's a reference to it in the next step. In the next step, we upload the JSON metadata to IPFS, and it does include a reference to the image, so the image has to be done first. Then we broadcast our mint transaction, and we wait for block confirmation, then we can view our token. So what is the kind of information that we're uploading to IPFS? If I just go back to the market for 1 second and I look at the first one that I minted, this is the JSON. You can see it's probably too small for you to read this, but of course this is an IPFS hash. I'm using the IPFS gateway ipfs.io/IPFS. Anyway, so this is our very short metadata JSON for that token. That would be this token here. So you can see that I didn't include attributes. You saw the minting form. It was very simplistic. It would be very easy to add that kind of stuff. And then you see we have IPFS hash here ending in FARQ, which is here. It's probably too small, but on the IPFS gateway, we have the same hash here. So this is the off-chain metadata, NFTs. Let's go ahead and mint one. Let me just do this for a sec. So I have an image here of a Ukrainian flag. We'll call this Solidarity with Ukraine. And we will show our support to Ukraine, you know, potentially by making this our PFP image. For anyone who doesn't know what that means, it's profile pic. So you can see that profile pics in NFTs are starting to become a thing now, with Twitter including the ability to add OpenSea NFTs as your PFP. So let's go ahead and we will try to mint the Ukrainian flag NFT. I'm going to cross my fingers before I click this button, and then I'm going to click. So here we get our Kepler pop-up. I don't think I can zoom in on this, but what it says is all of our entry point arguments for executing the WASM contract, the contract that we're going to be executing, the address is here. It's the same address as we declared in our environment file that I was showing you earlier. The entry point that we're calling, what I've highlighted here, it says MINT. This entry point is called mint. The parameters which we're sending it are the token ID, which in this case happens to be 5, as in it is the 6th token that I will be minted, because it is 0 indexed. It started at 0. The owner is my address. It's going to be the same address that we see here. And then the token URI, which is the IPFS, which has already been uploaded. And then we're not extending the base CW 721 contract with any specific extension. So we have null extensions to the minting. And we're just using the base functionality of the library. So I'm once again going to cross my fingers and click approve and see if we can get this thing minted. Now, we don't see it loading, but in a second, oh, it's loading all the NFTs, and you see that I gave the ability to view the logs. So we minted an NFT, hooray. And then here is the response that we got back from our PC. You see that the entry point which we executed on was called mint. It was an execution. It was not a query. And then if we look down further, we're going to see the attributes from our form and also the token ID. So let's just very, very quickly try to spin through what the code was that was doing that. So here we are once again, line 584 of app.view. I'll try to, okay, so this is the actual minting. This is probably the important part. The IPFS upload stuff happens before we call the minting, but I think the minting is the really cool thing that we need to look at. So just because of the way that I declared the token IDs, I just had to have them incrementing. So just in case there's other users minting at the same time, we just load all the NFTs before we do the mint transaction, just so we can make sure that we have the most recent ID. I left a note here. Of course, if multiple users are trying to mint in the same block, you could have a failure. And then here, when we create our entry point arguments, you see that this is exactly what we saw in our Kepler pop-up. And you can see that I also included a console log. So there are lots of debugging for you. If you're running the dApp and trying to do stuff, you'll see that I left you lots of helpful logs in here. I don't know if you can read that, but it's not too important. It's more for you to check out for yourself. We calculate the transaction fee. The calculate fee function comes from the CosmJS packages. That's gone over in the developer documentation. If you look at the guides, we only have one guide right now, which is creating your first dApp, and it is the increment template from the developer CLI. The dApp that I'm demonstrating to you right now will be added as our second guide very shortly. But I think the calculate fee should be covered somewhere in here, or if it's not, it's covered in a blog post. But suffice to say, what it's doing is, where was I? Yeah, it's calculating the gas fees that the user is going to need to be pay so that the transaction does not fail. And then, I mean, at that point, we're all set up, and we can broadcast our transaction, handle the loading, reset the metadata form. So you see that the form has returned to a pristine state after we got our minting log. And then we load the NFTs again so that the new NFT which we've minted is going to appear in a marketplace. And then we also refresh the user's account balance. Maybe it's not like super clear why we did that, but the reason is because we've consumed gas here. So we will have a slightly different balance of our gas. And you can see that now we have minted the Ukrainian flag NFT. But right now, I am the owner. If it detects, when you're looking at the market, if it detects that the address is the same as the user who is logged in, which happens to be this address, it says you instead of the address. If it's not you who owns the token, it's going to give their address. So what I'm going to do right now is I'm going to go to my NFTs, which is the only view that we haven't looked at yet. And we're going to see that I'm holding all the NFTs in this contract right now, except for this one, because I transferred it to this user. So what I'm going to try to do right now is try to transfer the Ukrainian flag NFT to Augusto. Just give me 1 sec, folks. I'm going to try to get Augusto's address here. Oh yeah, here it is. So I'm going to try to send this to Augusto's Archway address. Once again, before I click the dreaded button, I'm going to cross my fingers, and then I'm going to click send. Okay, am I able to actually, oh, that's so cool. I can actually zoom those too. Okay. Here we have our Kepler pop-up zoomed in this time. You see, we didn't include any metadata, or sorry, any any memo message. We don't need to. Okay. So now with the zoom, I was not able to see. Okay, so we are calling the transfer NFT endpoint. We include the token ID of the token which we wish to transfer, and we include the recipient's address. You see that these parameters are the same as you're seeing here. This in the dApp right now, the ID is a read-only field, so you can't change it by clicking on it. But of course, you can type in the recipient field. And the address that we typed there was Augusto's Archway address. So I'm going to try to send Augusto the Ukrainian flag NFT. Approve. So it's transferring the NFT. Oh, and then it has transferred. We see it now showing up in the logs. We see the endpoint which we have called is transfer in the contract. It was an execute type, which means it's not a query. So we are changing the state here. And the state that we are changing is this token has now been sent to this recipient. So what we see now is that because we refreshed the collection, this Ukrainian flag NFT, it no longer appears in my collection because I am currently on the My NFTs page. I no longer own that NFT as I have transferred it to Augusto. However, if I go back to the marketplace, we see that Augusto, his address, is now the owner of this NFT. So let's just quickly review the steps. For transferring an NFT, this is happening at line 713 of app.view. As you saw, we collected form data. Now we had the token ID was set as a read-only value. So the only form data that we need to collect from the user was the recipient address, in this case, Augusto. After we have that data, we can broadcast the transfer transaction as you saw, then wait for block confirmation and verify that it's been transferred to the recipient, which we saw as well showing here. And the code to do this, let me just get the line again, sorry, 713, it's pretty small. Much less steps compared to NFT minting. What was that again? 713. Okay, so scrolling down to 713. Getting there. Oh, we're almost there. We're close. Oh, too far. Yes. So we have a handler function, which is going to call our function, which actually does the transferring. Oh, that's not what I wanted to do. Wow, that was annoying. I can't believe I just did that, folks. I pressed page down. Okay, so transfer NFT. First, we just check we have all the right things before we send a transfer that's not going to go through. The entry point is created in a very similar manner to the previous ones, and all entry points, you know, they share this format. And you notice that what is inside of the entry point, this part, is pretty much identical to what you see in the pop-up that you get from Kepler when you go to approve the transaction. And then the rest of this is just kind of like state management for the dApp. You tell them that we're in the process of transferring it to the recipient. Of course, just like minting, we have to calculate the fees so that we apply the correct gas charges so the transfer transaction will actually go through. Provided we've done that all correctly, we can go ahead and we can execute and broadcast the transaction. And then, you know, provided everything is good, because we have the asynchronous await syntax, you know, once we reach this line, we know that we've transferred it. And we can update our status in the dApp. And then if we get logs, we can display them to the user. And of course, just like minting, again, we are going to reload all the NFTs. So all of the metadata and ownership data is current in the application. And then once again, we're also going to update the balance of the user who sent the transaction because they've paid a little bit of gas. So their Constantine balance down here has gone down a little bit. So it looks like it was, I think it was 597.4 before. So it was about 0.3 Archway Constantine arch that it cost. And of course, if you look at the code, that makes sense, right? Because the way that we estimated the transaction, I would just scroll up. You see that going down by a value of 0.3 makes sense because it's reflective of that value. It's just a fractional representation of the gas price that we were sending it. And I think that's it for the demonstration. So if anyone has questions for either myself or Augusto, I think now is the time. Just look at our beautiful Ukrainian NFT one last time, and then I'm going to turn off the presentation.
Did we address all of the, I saw some questions coming in, and I think Augusto might have been handling them with regards to the, if I use the on-chain NFT metadata template, is the token ID generated automatically by the blockchain? Were you addressing those, Augusto?
Yes. So yeah, as I was explaining in the chat, right now with the code template that we used, the user needs to specify the token ID on the moment that they are doing the transaction. So these can be easily changed on the contract side. So we can just override the message, and as I demoed, like as I demonstrated with the how to override specific messages for transactions, we could change that, and instead of requesting the user to specify the token ID, the contract can handle it and do a sequential indexing of the token ID. So yeah, this way we don't run into concurrency problems with two users submitting a transaction at the same time with the same token ID.
Okay, and that then I guess you also answered the what would be the solution for multiple people trying to mint NFTs in the same block?
Yes, exactly. It's related to that.
Okay. Okay. I'm just checking that we got all of the questions.
I'm just trying to answer.
The Kepler wallet are connected to the testnet. Could you show us how much incentives have been distributed to dApp developers on the testnet so far?
I haven't really been tracking it right now. That is sort of like on the agenda for very, very soon. I think what we'll do is I will build another dApp that sort of will be like a tool for people to use, that you can enter your contract address and get the metadata and metrics for the gas for your specific application based on contract value. Right now, it's really difficult because you have to do a lot of searching around and detailed analysis. And if I wanted to show it to you right now, I just feel like you'd just be watching me like click around trying to find it for too long. But just give us a couple of weeks. That's something that's in the pipeline for sure.
Okay. So, and then I think where can you start from the beginning? Your new to blockchain code went above the head. I can relate. Where can I start from the beginning? So I guess the question is it Naushad? There's a lot of different beginnings within the Cosmos ecosystem per se. If you're not part of the, so I shared the Archway Discord and the Archway sign up, But I will also share just quickly if I can get to it before too long, the Cosmos Discord channel, because this is a great place outside of also Archway, where you can go and get new developer resources. Also, a little bit of a plug, we're working on a developer onboarding program for Cosmos. So I don't know if that answers your question, but there are a lot of resources. Archway is a good one to get started with because it's relatively easy in the grand scheme of things, as is Starport. So you could also check out Starport. And hopefully that's an answer. And then we also have a lot of these code with us on the YouTube channel as well. And I guess the point about the rewards, I'm not sure, do we have or do you guys have tokenomics out yet on Archway and like the reward structure for developers that we could share, or is that still kind of in the works?
Yeah, I think, let me see. The information that we have right now is in the docs,
Okay.
in the overview, in the about section. There is a section called economic overview. It's
Okay.
not a huge amount of information. I'm just putting a link in the chat right now. So that is the information that we have publicly available about economic overview. There may be some stuff discussed on our Medium blog, but I think it's just pretty much the same information you're going to find on this link anyways.
Okay.
Oh yeah, and the light paper, that's a crucial place. Yeah, hopefully once we have the gas tracker dApp, where you can look at all the metrics for your contract by putting your contract hash into a search field, then we'll have a little more information we can flesh out publicly for the economic models.
Okay. And I don't know, sorry, Mike, you might be more on top of this. Maybe we could share a link with everyone on the validator sign up. So for the upcoming incentivized testnet for Archway, I would assume that's a good way to start getting involved on the more operational side, like not necessarily building smart contracts, but getting involved, playing around a bit with potentially Archway. I'm not sure if we can add that link there as well. I think it's a Google form if you guys are interested in signing up for that. So I think we're all good. We're all caught up on the questions, right? So, yeah. And we're almost at the time. So if we have no more questions, then we would love to see you guys on the Archway Discord. Sign up, follow us on Twitter. It's a really cool project. So, and thank you everyone for your time. We'll be sending another email with the recordings of this one and Starport tomorrow in case you missed it. So thank you everyone, and we'll see you on the next Code with Us.
Yeah. Thank you all.
Take care, everyone. Thanks for coming out.
Bye.
Bye-bye.